Welcome back to the deep dive. We are jumping right back into the Sampo Protocol today.
Yep, glad to be back. We've got a lot to cover.
We really do. This is part 5 of our ongoing exploration into this whole ecosystem. And today we're zeroing in on port 809.
Right, which is the DAO quantum identity protocol.
Exactly. But before we even get into the heavy cryptography of that specific port, I have to bring something up. I was scrolling through LinkedIn the other day.
Oh yeah, the Sampo AI OS page.
Yes, you saw it. There was this fascinating post highlighting 2 of their employees.
The one with scriptwriter and Oracle.
Right, and I was just totally captivated by it because you have these 2 clearly brilliant human minds, and they're having this intense public debate about the philosophy of the tools they're building.
It's rare to see that kind of raw intellectual exchange out in the open like that.
It really is. I mean, treating complex infrastructure with that level of philosophical rigor, it just shows the caliber of the people behind this project.
Absolutely. It humanizes a very abstract system.
It does. And, reading that actually made me look at the system overview with a fresh set of eyes. And I noticed this unified architectural DNA across the whole thing.
You're talking about the prefixes.
Yeah. If you look at the 11 DAO nodes, every single one of them has a project ID that begins with the exact same syntax. It's op.
Right.
So like the quantum identity protocol we're looking at today is labeled op2db957dbb5.
It's a fascinating little detail, really,
Yeah.
because it completely challenges that whole assumption of a purely chaotic, organic, decentralized network.
Exactly. It's not just random code floating out there.
No, it's a deliberate variable.
Right. And my working theory is that op stands for operator, like a specific signature left by one of these brilliant innovation architects, maybe even scriptwriter or Oracle.
That makes a lot of sense.
It reads like a centralized human touch,
Yeah.
deploying this highly coordinated ecosystem from the top down.
Well, and if we assume there is this unified operator architecting the whole thing, we really have to look at why. Like, what is the massive existential threat this specific protocol, port 809, was designed to neutralize?
Oh, man. Yeah. The sources outline this threat, and they call it Q-Day.
Q-Day, right.
And for you listeners who track the crypto space, this isn't just about computers getting a little faster.
No, not at all.
It's about quantum states basically rendering our current prime factorization models completely obsolete. The documentation is honestly pretty stark. It says, everything secured today becomes publicly readable tomorrow.
Which is a terrifying thought.
If Q-Day happens, global digital trust literally evaporates overnight.
Yeah, and to understand why that evaporation is so absolute, we kind of have to look at the mechanics of our current encryption standards.
Like RSA or elliptic curve?
Exactly. They rely entirely on the sheer mathematical difficulty of factoring massively large prime numbers or, solving discrete logarithms.
Right. It's a brute force problem for a classical supercomputer. Yeah. Checking every possible combination is a brute force effort that would take literally millions of years.
But, and this is where it gets crazy, a quantum computer running Shor's algorithm doesn't brute force the problem at all.
No, it bypasses that entirely.
From my understanding, Shor's algorithm leverages quantum superposition to evaluate multiple possibilities simultaneously, and then it uses quantum interference to basically amplify the correct answer and cancel out the incorrect ones.
It collapses the probabilistic math.
Right. So instead of guessing locks for 1,000,000 years, it finds the underlying periodicity of the cryptographic function in, hours, minutes?
Exactly. And that is the core mechanism of the threat here.
Wow.
The moment a quantum system achieves enough stable qubits to actually run Shor's algorithm at scale, those foundational math problems are just solved. Done.
So every password, every encrypted file, every blockchain ledger?
Laid completely bare.
Yeah.
Anything that relies on standard public-private key pairs is instantly vulnerable. I was trying to visualize this shift, and the old analogy people use is like a massive steel bank vault suddenly turning into transparent glass.
Right. I've heard that one.
That doesn't quite capture the physics of it, I think. It's more like the laws of physics that govern the vault's locking mechanism suddenly change.
Oh, that's a good way to put it.
Yeah, the vault doesn't become transparent. It's just that the fundamental concept of a lock suddenly ceases to exist in this new quantum reality.
I like that. And I actually take that a step further and apply it to the Sampo ecosystem specifically.
Okay, how so?
Well, think about what we're looking at. We have this network of autonomous AI nodes. They are trading energy, they're analyzing geopolitical risks, executing smart contracts.
Right, highly sensitive stuff.
Exactly. If their cryptographic foundation is rendered non-existent by Shor's algorithm, the entire network is hijacked instantly.
There's no buffer.
None. So transitioning to post-quantum security isn't just like a roadmap feature they can push to Q3 or whatever.
It's not a nice
But
to have.
no, it is a fundamental survival requirement for the architecture to function at all.
Which leads us directly into how Port 8009 is actually engineering a solution to this. Because if the old static locks are broken, what exactly are they doing differently?
Right, how do you build a vault that quantum computers can't see through?
Exactly. And the sources detail how Port 8009 acts as this post-quantum decentralized identity service. And it uses a triad of defenses.
The three pillars, yeah.
Right. Algorithm-aware identifiers, dynamic verifiable credentials, and audit-style blockchain anchoring.
Let's focus on the algorithm-aware identifiers first, because I think that is where the architecture becomes truly agile.
Yeah, break that down for us.
So in legacy systems, an identity is tethered to a specific algorithm, say SHA 256 or a very specific elliptic curve.
Okay.
If that specific algorithm is compromised, the identity itself is essentially burned and must be destroyed and reissued.
Which is a massive logistical nightmare.
Exactly. But Port 8009 decouples the identity from the static algorithm. The metadata of the decentralized identifier, the DID, includes these dynamic state flags.
And those flags indicate which post-quantum cryptographic suite is currently active.
You got it.
So let me make sure I'm following. If a new quantum computing technique suddenly threatens like a specific lattice-based cryptography profile,
Right.
Port 8009 can just dynamically rotate the identity's underlying security over to a newer, maybe hash-based or multivariate algorithm without having to burn the actual credential.
Exactly. It rotates the lock without changing the door, so to speak.
Yeah.
It creates a living, breathing defense mechanism.
That is brilliant.
It is. And this agility is paired with continuous revocation tracking.
The audit-style anchoring part.
Right. If a credential state is theoretically compromised or even just outdated, Port 8009 doesn't really flag it in some localized, centralized database.
Because that would be a single point of failure.
Exactly. Instead, it anchors that specific state change into an immutable blockchain audit trail.
So the entire decentralized network achieves consensus on the revocation instantly.
Yes, utilizing cryptographic state proofs.
Okay, so we've established this incredibly robust post-quantum trust anchor. The network survives Q-Day.
Right. The data is safe.
However, and this is a big, however, a highly secure system is totally useless if you can't verify the state of the participants in a practical way.
Exactly. Security versus usability.
Right. Securing data against quantum interference is one massive hurdle, but allowing autonomous nodes to actually use that data without constantly exposing their raw inputs, that's another beast entirely.
And that is the operational heart of Port 8009.
Yeah.
The implementation of selective disclosure.
Through hidden attribute commitments.
Yes.
The documentation actually provides a very stark visual comparison between legacy claim verification and their new proprietary method.
It's a great graphic.
It really is, because in the legacy model, proving a single claim basically requires exposing your entire raw dataset. Like, if a node needs to prove it operates within a specific geographic jurisdiction for, say, regulatory compliance. Currently, it has to broadcast its exact IP, its physical data center address, its corporate registration details.
You're handing over the entire data payload just to satisfy one simple Boolean condition.
It's an all-or-nothing approach.
Which is a massive vulnerability, especially in a network that's expressly designed to scrape and trade high-value data.
So Port 8009 solves this using hidden attribute commitments, which, operates on the principles of zero-knowledge proofs.
Right.
And I was thinking about how to explain this, and a lot of people use the bouncer at a nightclub analogy.
Handing over your ID to prove you're 21, but the bouncer sees your home address and height.
Exactly. But to move past that basic analogy, what we're really talking about here is a mathematical challenge response mechanism.
Okay, let's hear it.
It's as if you want to enter a restricted area. And instead of showing the guard your clearance badge, the guard just issues you this insanely complex mathematical puzzle. And the puzzle is specifically designed so that it can only be solved if you genuinely hold, say, a level 5 clearance.
I like that.
So you calculate the solution on your end, hand the math back to the guard, and the guard just verifies the math checks out.
And the output on the guard's end simply reads, verified, condition met.
Exactly. The relying party never sees your name, your exact clearance level, your biometric data, none of it.
They only see the cryptographic proof that the underlying condition is true.
The math satisfies the requirement without leaking the raw input.
It's elegant.
It really is. And while, privacy advocates absolutely love this concept for human data, the sources make it very clear that the primary driver here is actually machine-to-machine interaction.
Oh, absolutely. This selective disclosure is vital for autonomous operations within the Sampo ecosystem
Why is that?
because machines simply cannot afford the computational overhead or the security risk of exchanging massive raw data payloads for every single microtransaction.
That makes sense. It would just bog the whole network down.
Exactly. And the workflow outlined in the sources demonstrates this perfectly. Let's say we have an AI node. Maybe categorize it as an orbital satellite or a remote grid monitor.
Okay, a satellite.
And this satellite identifies a highly profitable renewable energy arbitrage opportunity.
Right.
It spots a sudden surplus of solar energy in one regional grid, and that energy needs to be routed immediately to another grid to prevent, like, a load balancing failure.
So that trade needs to execute in milliseconds.
Yes. But the receiving node has to verify the counterparty first.
Right. It needs to know, is the satellite actually an authorized Sampo node?
Does it hold the post-quantum credentials to authorize a high-volume energy transfer?
Right. And in a standard Web 2 architecture, they would have to initiate this heavy API handshake, exchange full SSL certificates, query a centralized database.
It introduces so much latency and multiple points of failure.
But utilizing port 8009, the satellite just sends a lightweight verification ping containing that hidden attribute commitment.
Exactly. And port 8009 checks the algorithm-aware DD against the blockchain revocation registry, runs the zero-knowledge verifier circuit, and instantly confirms the unrevoked credential state.
It just outputs that condition met Boolean,
And the trade executes on the ledger instantly.
creating literally zero human bottleneck.
Zero. It engineers an environment where distributed autonomous agents can interact, negotiate, and execute complex, high-stakes operations at the speed of light.
With absolute cryptographic certainty.
Yes, all while maintaining total operational security regarding their underlying state data.
Okay, I am completely aligned on how revolutionary that execution is. We are looking at a brilliant post-quantum selective disclosure engine.
It's top tier.
But while I was digging into the actual source code provided in the repository, just to see how this verifier circuit was actually built,
Oh, I know where you're going with this.
I noticed a glaring discrepancy in the architecture.
You're talking about the divide between the public repository and the actual production environment.
Yes. What we are looking at in the public GitHub repository is not the live engine executing the zero-knowledge proof.
No, it's not.
The public repo is this entirely contained, sterile simulation. It entirely reframes how we should view the transparency of these DAO nodes, honestly. The code we can see is merely the code the operator allows us to see.
Precisely.
Okay, let's take a breath and synthesize what we've unpacked today. Because the implications of port 8009 completely recontextualize the entire Sampo ecosystem.
We covered a lot of ground.
We started by mapping the existential mathematical threat of Q-Day, right? Where algorithms like Shor's threaten to basically collapse the probabilistic math securing global digital trust.
Right. And then we examined how port 8009 neutralizes that threat by decoupling identity from static algorithms.
Utilizing those algorithm-aware DDs and immutable revocation tracking. We then explored the critical application of that trust via selective disclosure. We looked at how hidden attribute commitments operating as cryptographic challenge-response mechanisms allow AI nodes to verify complex authorization states without ever exposing raw data.
Resulting in zero bottleneck autonomous machine trading.
Yes. And finally, we analyzed the strategic IP architecture of the deployment itself. That calculated division between the public Python showroom designed for enterprise integration and the vaulted Rust and Go production engines protecting the protocol's core technological advantage.
It paints a picture of a network perfectly optimized for securing digital trust and data routing.
It does. However, while analyzing the system logs generated by these verification circuits within the DAO Hub architecture, I notice an alert protocol that fundamentally shifts our focus.
Uh-oh. The transition from digital verification to physical state awareness.
Yes. The source material maps out exactly what happens immediately after the network finishes verifying these hidden attribute commitments.
What does it say?
The system log states, and I quote, "Node identity verified. Scanning for active environmental inputs."
Oh, wow.
At that exact moment, the telemetry routes beyond the internal DAO hub ledgers. It connects directly to external physical hardware sensors.
So the protocol steps out of the cryptographic sandbox and interfaces with the physical environment.
Yes. And for our next deep dive, we are taking the Sampo system physical.
I can't wait.
We have discovered port 811, which is designated as the Dynamic Resilience Energy Suite, or DIAS.
DRS. Okay. This represents the moment where the abstract concepts of algorithmic risk and identity verification become highly tangible environmental realities.
Very tangible. The dashboard imagery we pulled from the port 811 system alert for part 6 shifts away from Swagger UIs and API endpoints entirely.
What does it show?
It opens into an active observatory view. The feed reveals a Northern Hemisphere drone network currently tracking the skies directly over Helsinki. Yeah. The drone telemetry is feeding real-time ambient environmental data back into the post-quantum hub. It is reading a localized temperature of 7.9 degrees Celsius, with wind speeds registering at 2.9 meters per second.
That is highly specific, localized telemetry being ingested by an autonomous global network.
But the drone isn't just logging weather patterns for a database. This real-time telemetry cascades into a critical physical threat assessment algorithm.
A threat assessment.
Yes. The interface culminates in a flashing red alert. The drone has calculated a 78% flood risk, projecting an imminent water level rise to 7.8 meters.
So there's a literal storm approaching the infrastructure.
Exactly. And I want to leave you, the listener, with a chilling question to analyze before our next session.
Bit of a big one.
We have spent today detailing exactly how these AI nodes use post-quantum cryptography to verify each other's identities autonomously. We know they are capable of executing complex energy trades and data routing in milliseconds without a single human bottleneck. But what exactly does a fully autonomous post-quantum AI network do when it calculates a 78% probability that a physical flood is about to destroy its own localized hardware?
How does an artificial intelligence engineer physical resilience against the natural world?
That's the question. I hope you'll subscribe and return next time as we unpack port 811 to find out. Until then, keep digging.